Welcome everyone to the this episode of the Uplink. For those of you who have not joined us before, this is the I would say bi-weekly or semi-weekly webinar that Helium does with members of the community, typically companies like Nobel Systems, who we'll get to in a second, who are building on top of the network, but oftentimes just pure partners who are providing technology to the Helium ecosystem. So welcome, thank you for joining us. So we typically run about 30 minutes. We'll do some questions and answers sort of along the way, but we're gonna focus here, as we normally do, on the solution that's using the Helium network. In this case, it's a parking lot monitoring infrastructure built by Nobel Systems with the help of some partners from the Helium and LoRaWAN ecosystem. It's a fantastic story. People are really going to enjoy it. We've got Aretha and Dan and Tanmay here from Nobel, and they've all sort of played a specific role in getting this deployment up and running on the Helium network, and we're going to talk about all of that. Just a point of order, we do have the ability to sort of send questions into the Zoom chat. So if people want to do that while we're doing it, or while we're having the webinar rather, please do so. We'll try to pick them up as we go. I'll do a quick introduction here about Helium, and then we're going to kick it over to talk to Nobel and the team and get most of the details. So if all three of you are ready to go, let's do it. So for those of you who don't know me, my name is Mark Phillips. I run business development for Helium. You can find me in Discord pretty much constantly. And I've been at Helium for about 7 years. I think actually my 7-year anniversary is the first week of February, which is pretty wild. So I'm going to let the Nobel team do introductions when we get to their slides. So I'll hold off on introducing that team. I could definitely not do them justice. For those of you who are not who are new to Helium, which hopefully a lot of you are, we were founded in 2013, as I just mentioned. We've got venture backing from big names that you've heard of, Costa Ventures, First Mark Capital, Google Ventures, and then companies like Harvard Steam Boiler and SV Angel, and then most recently, Multicoin Capital and Union Square Ventures, who led the, Series C round in Helium in May of 2019. I usually say May of last year, but it's not 2020 anymore. And so about 2.5 years ago, we set about on this new mission to build what is at this point the largest public LoRaWAN network in the world, which is pretty wild. We've gotten here in just about, I think it's under 24 months, probably closer to 18 months. We didn't start shipping hardware until somewhere through, like halfway through 2019. And so, although LoRaWAN has been around for probably 7 or 8 years in its current form, we managed to build with the help of our community, and we'll talk about how Nobel is sort of part of this, the largest public LoRaWAN network in the world. Someone recently told me it was the largest contiguous wireless network in the entire world, which is pretty wild. You can get Helium coverage in something like 55 or 60 countries at this point, which is ridiculous. The biggest thing here is probably the coverage map for someone who's new to the network. So you can click on this coverage map here and get a look at all these new hotspots that are coming online. So these are ordered in terms of most recent onboarded hotspots. You can also zoom in on a part of the country. So for example, I'm in this part of the United States, up in the Northeast here, just outside of Boston. So you can come and look at all the coverage here in Boston, which is pretty great. Or you can sort of zoom out and go somewhere else, or you can type in a city, for example, and get yourself down to the Boston area. So highly recommend you spend some time on Explore. Again, this is the best place to learn about what's happening in the Helium network. If you don't have a hotspot up and running, hopefully you'll have one soon, and you can be on the coverage map. So when it comes to running hotspots, we made a huge announcement today, which I wanted to sort of highlight before we kick it over to the Nobel team. So if you've been in the Helium ecosystem for any number of months, the biggest problem that we have is supply when it comes to miners. And when I say miners, I mean a gateway or a hotspot, something that's providing coverage in the Helium network and earning HNT for doing that. So today, we announced that there are 3 new manufacturers that are shipping hotspots that have been approved by Helium and something called the Decentralized Wireless Initiative, or DY. If you go to helium.com/mine, you can get details on all of these new gateway products. So this is the original OG hotspot, as it's often called. And then over here, we have the rack hotspot miner, which is the second to market. And then we're adding, the community is adding things from Nebra and a company called EasyLink in, and another one called Syncrobet. And so you can get all the details here as you sort of scroll down. And so highly encourage people to head to helium.com/mine. If you haven't picked up a hotspot yet, this is going to be the best way to do it to join the network. Okay, so Without further ado, I will hand it over to the Nobel team. Are you ready to take over, Aretha?
Okay.
Go right ahead.
Oh, you see my screen?
Yep, looks good.
Oh, hello. My name is Aretha Samuel. I have my teammates here, Tanmay, Thakur, and Dan Brennan. I am the CTO of Nobel. Tanmay is our IoT engineer. Dan is our business development. And so Nobel Systems is who we are. We specialize in building IoT devices and asset management software for utilities and cities. We have over 25 years experience building, software for them. We have customers in USA and Philippines. Our main product, it's called Geoviewer. It combines IoT, asset management, and mapping technologies for utilities and cities to manage their assets. So this is our product. We have a desktop application, a web application, and a mobile app, and we build IoT sensors too. It's a real-time like operations management solution. We basically enable, like we create like a kind of a digital twin model of water and sewer networks by using IoT sensor data, machine learning to forecast demand and pressures. And we collect also like maintenance information on utilities assets. Here is I just want to explain, this is a pressure sensor and for water utilities, and they place these sensors at different spots in their network. And so the utility can get real-time pressure readings.
Can you, hey, Aretha, would you mind describing what a digital twin is to people who might not understand or who hadn't heard that term?
Oh, a digital twin, basically like a digital kind of copy of how their network is working for utilities. So basically we want to get as much real-time data, real-time like demand. And so one way to create a digital twin is to put devices, IoT devices here. And then now utilities are going into smart metering, which gets very accurate demand consumption data. And then we have real-time SCADA. So SCADA is like the supply. So all that real-time information will create a kind of a very accurate digital model of their network.
I got it. Thank you. Super helpful.
And so we have, this is more of our products. We could show statistics of work orders completed and then hours and how much the cost is. And we could show it on the map. And then, this is basically our Geoviewer mobile platform. So the field guys can take this app onto the field, collect data, and then so it's basically to help the utility manage their assets, and also to do more intelligent things by combining IoT and artificial intelligence as well. So we have a customer, Huntington Park, and because we are an IoT company, we thought IoT would be useful for solving their issues. So they finding available parking for its customers can be challenging, and the city would like to get rid of, manually paying for their spots. And also the parking enforcement needs a better way to track who paid. And basically they wanted their citizens to easily pay for its parking. And so we decided to install like kind of parking sensors under each parking spot. And show availability, vacant, occupied within an app. So we installed sensors here to help the users find available parking. And the cities can view, in real time how their spots are doing. And then we decided to also make it digital, so you could just pay for your parking through your phone. I'll now give it over to my co-worker, Tanmay.
Hi guys, so I'm the IoT engineer at Nobel Systems. So basically, I would explain you what's the architecture of this complete system is like we have a bunch of sensors, about 1,460 sensors at several parking lots at Huntington Park. And the first part about this complete system is having those sensors installed at each parking spot. And the sensors are called as PNI place spot sensor. So it's basically a UV ray sensor which senses if there's any metal on top of it. So whenever we drive a car on it, it changes its status to 1 or 0. Basically, it's binary numbers which gives us the status whether it's occupied or not. So once we installed these sensors, we had to decide on what type of gateways to use. So fortunately, Helium was very much compatible, or they have a good support with getting the any sort of gateways on board to their network. And we chose Multitech because they were very much had a good range, a good IP67 rating gateways, and we got it on the Helium network. And basically, this parking lots, there are total 18 gateways which are connected, and they're sending data to the Helium console. So now all the data is available on the Helium console, and we at Nobel System are very much capable of using all the APIs and pushing the data to our inbuilt application, which is called the Geoviewer parking app. So the city uses this Geoviewer parking app for for the public. So anytime you go to any of the parking lots at Huntington Park, you will be installing Geoviewer parking app and using the data from the sensors and basically booking a parking spot. So all this PNI place spot sensors, the LoRaWAN gateway, the Helium cloud is integrated into Geoviewer parking application. And now you can see some of the pictures here of the actual deployment. We have in the first picture is a PlaySpot PNI sensor, which is currently installed on each parking lots. The black spot is a PNI parking sensor. And besides those are the two gateways from Multitech, which are installed on a signal pole. And those are communicating smoothly, sending all the data packets from the parking lots to the gateway and from the gateway to the cloud. Um, these gateways are working on a frequency of 915 at frequency band 2. If you guys are familiar with the LoRaWAN, I'm sure you guys are. Um, and so,
Hey, sorry, Tammy, can you go back to that last slide? I want to ask you a few questions because this is some of the coolest stuff that happens on the network. It's just awesome. So so this is the place pod sensor all the way to the left. And you're using two different models of the place pod, right? I put a link, by the way, to the place pod site. It's by a company called PNI in chat. So there's two different place pod models that you're using, right?
Uh, basically, there are two different PlaySpot models, which is in ground and just on the ground, but we are using in ground version.
Okay. And can you talk us through the process that the city had to do to actually put that in the ground? How did that work?
Basically, the city first had to do a site survey of what would be the range of gateways that will be needed and what type of sensors that would be needed. So, I mean, that's a typical IoT architecture which you had to decide before deploying any system. And when they did a survey, they found that they would need a in-ground parking sensor because basically, like for any parking spot, I guess the best part is to put it in ground. And doing a site survey of the range for gateways, like they selected different gateways, and they did a range test for each of the gateways. It looked like Multitech's gateways had a much higher range for communication, and they that would eventually reduce the number of gateways required, thus reducing the cost of the overall project. So they decided upon 18 gateways. I remember they telling me that if they would have been gone with some other vendor or some, like I'm not naming the vendor, but some sort of vendor, they would have needed like 26 gateways for the same parking lots. And that was the decision, and our challenge was to get these gateways onto a reliable network, which is we got it on Helium
Sure.
because of the compatibility. Um, yeah, basically that was the
That's great.
site survey they did.
And so the sensor itself, it's in the ground. There's got to be some sort of antenna on it, right? Like where does that come into play?
The sensor doesn't have an antenna. The sensor works on ultrasonic communication. So
Mm-hmm.
basically, this signal can penetrate about 5 feet below the ground.
Huh.
And it can sense any metal on top of it. So, for example, just to give you an overview, like if you keep a sensor on your desk and hover over a laptop on it, it would sense whether something is on top of it or no. The same concept goes onto a parking lot, each parking lot. Whenever a car drives on top of it, the sensor continuously transmits a ultrasonic signal. Whenever the ultrasonic signal is blocked, it means that a car is on top of it.
Mm-hmm.
That means the parking lot is occupied. Whenever that sensor is not, whenever the UV ray is not, the UV ray is not interrupted, it means there is no car on top of
Sure.
it. So basically, that's how it determines whether it's vacant or not.
Fascinating. Okay. All right. So a couple more questions for you, and then I'll let you move on. We got a few from the chat here. So let's see. John Fitzpatrick was asking what they use for backhaul. So these use cellular backhaul, right, to backhaul the data from the sites?
Yeah, they use
Okay.
cellular backhaul.
Okay. And then does the solution work in cold, snowy weather climates? So obviously Los Angeles not typically going to have snow on the ground. But let's say, for example, it was covered in snow. How would that work?
100% the sensor would work in snow because
Mm-hmm.
as I told, the sensor can work 5 feet below the ground and it can still transmit the ultraviolet rays through it for to sense any metal on top of it or no.
Nice. Okay. And then does it work with motorcycles? What happens with a motorcycle?
I can't guarantee that it would work for motorcycles unless the parking spot is very narrow and
Right.
you can make sure that it's always on the sensor.
Got it. Okay. And then one last question, actually, that Kathleen just asked. What's the expected battery life for this in the ground? When the city installs it, how long is it supposed to be there?
The expected battery life is 5 years.
Okay. Wow. That's awesome. All right. Cool. Thank you.
So sorry, it's so small, but this is how our parking lot application will work. So they'll open it, sign in, and then you can see all of the vacant spots as you drive in. So you can plan your parking, and then as you drive in, it will turn red, and then it will pop up, and then you can book and then pay, and then that will be sent over to the parking enforcement.
And your cloud architecture, so sensors talking to gateways, talking to the Helium network, through to the cloud. You're running on, do you have your own private cloud? Is it Amazon? Remind me what cloud infrastructure you're using?
Yes,
Yeah.
Oh,
Amazon?
yeah,
Yeah.
Amazon.
Okay, great, thank you.
Yeah. So the sensors, gateway cloud, API, and then to the app.
Perfect.
And then here's some more screenshots. Like red means the car just parked in that slot, and then it's occupied. And so it sends this in real time. Within a couple of seconds, this data gets updated. Yes, and there's some a Helium dashboard, and all of those packets from the Helium, the cloud, it comes through to the app through an API. Yeah, go ahead, Tanmay.
Okay. Yeah. So I'll talk a little bit of why we chose Helium for this. First thing was basically we had to make this project as cost effective as possible and make it cloud managed. Helium is sort of very much cost effective for the application which we are using. Then basically the scalability of this complete project is kind of huge for us. because it's like 1490 sensors, managing them year to year and still getting everything to work, it was kind of challenge. So we realized that Helium network, you don't have to do too much management as such, but keep updated whatever you have and you're good to go. Then the next thing was the latency of communication. We wanted to be as less as possible. So when we did like a research about Helium network, it looks like the latency of communication for the LoRaWAN was sort of very less, and we could get everything on board as soon as possible, and the sensors would talk to each other without any huge RF antennas or wiring and all that stuff. So that was good. uh, Helium network provides the extended network range beyond the wireless services. What I mean with this is, um, we were very much familiar with only using cellular networks for the small applications, and when we realized LoRaWAN can be used, because first thing we had about LoRaWAN, oh, this is not completely tested, or this is not something that go into production. But when we realize that Helium has something that is already deployed, there are use cases about it, we started researching about it, and looks like that was something that we could put into production. And that's why we chose Helium. And actually the next thing was, multi-tech gateways were already chosen by the city, so we did not have the freedom to actually choose like the gateways then the network. We already had a fixed plan from the city that you have to use this multi-tech gateways, and then we have to select a network. So we basically had to choose something that is 100% compatible with the multi-tech gateways. There is proper documentation on how to get these gateways onto Helium network, the configuration, and all the sort of programming we did on these gateways. So all that documentation was clear cut available from Helium. So it was like a smooth path for us. So that is why we chose Helium.
And so while we're on this, Tanmay, before you get to the demo, just a few questions that have popped up. So you've got 18 of these gateways sort of out there running as part of this application. What's the general geography? Are they all scattered far apart? Are they close together? What's the general sort of footprint of all the 18?
For the installation, the basic motive based on the site survey was that each gateway should be in the range of 2 miles from each other.
Okay.
But I know that each multi-tech gateway is capable of a range of about 7 miles ideally. But looking at the geography at Huntington Park, there are sort of a little bit trees and some sort of taller buildings that could limit the range of these gateways. So because the city didn't wanted to take any risk with the sensors going out of range in real time, they decided to install it 2 to 3 miles close to each other.
I don't know much about the geography of Los Angeles or that area, but I do know that our coverage in Los Angeles is quite fantastic. So I would not be surprised if this deployment, I know for a fact that this deployment is contributing to other people's network coverage, but also you're probably routing data through things besides the 18 that you've deployed. And for anybody who wants to take a look at the coverage in Los Angeles, just go to mappers.helium.com. I'm tossing that in the chat right now. And you'll see data coming, or you'll see the mapped coverage in the parts of Los Angeles where these gateways are deployed. Okay, so let me ask a few more questions here. So Andrew's asking about trash and other metal debris in the roadway. I mean, obviously, if someone drops a metal plate over this thing, it's probably not going to work as effectively.
Yeah, that's right. It's not going to work as effectively as it should be. It might consider the metal debris as a car.
Okay, so we don't like metal debris. Right, that just acts as a car. So you think there's actually be a great way to save yourself a parking spot, I guess. Oh, maybe. Okay, so what is the power source for the sensors?
It's a battery.
Okay.
It's a lithium-ion battery, with about 500 mAh of power.
Okay, yeah, and I dropped the link to the sensor in the chat, so people can probably find the data sheet on the PNI website. Okay, there's John. So Armin is asking how many sensors are deployed now? So I think you said about 1,500, 1,460?
1460, yes.
Okay, and then does the town have plans to grow? I mean, I know that you guys will sell this similar application to other towns and cities.
Right.
Are there expansion plans for this specifically?
But definitely, there are much bigger expansion plans for this.
Okay, cool. And then for those of you who don't know Armin, by the way, he runs a great podcast called The Hotspot. Maybe he can pop a link into the chat and people can check that out. And then let's see, a couple more, and then we'll have you move on and we can take the rest in Q&A. So let's see. Mark Beatty, how do you enforce non-payers? Is it a photo of license plates? Like, what are there any features in the application that would force people not paying for spots? Or are you forced to pay? Meaning, like, if I just roll into a spot and I haven't paid for it, what happens? I think is the question.
Oh, so yes, if you haven't paid, if you've paid, it sends it to the parking enforcement apps software. T2 is what they use, and so if they have not paid, then it shows up in their app that they have not paid, and so they will get a ticket. So
nice.
yeah,
Okay.
so they have to pay.
No free spots, as it were.
No free spot.
All right, then one last question. So Keith was asking, if a parking space had been within range of a hotspot, would that have, or, you know, a part of the Helium network, would that have allowed you to skip adding your own hotspot? So the short answer is yes, it would, Keith. But you know, as Tanmay had mentioned, the city was very insistent on making sure that the coverage was built out and you know, additionally resilient. So maybe in the future, you know, I can see a situation where, as Nobel expands this, they can just show coverage maps and say, listen, we know for a fact that there's very good coverage here in this part of town. You can save yourself the 18, you know, times $600 for the deployment or whatever those gateways cost for multi-tech. So that's that. Okay, carry on if there's other slides here to finish up.
Oh, okay. I'll just play like a demo.
Oh, perfect.
Just showing a car, so it goes over this parking spot, covers the sensor. Then the person will open their app, and then they will see that they are on this occupied spot. Then they will just book it. They can add their license plate, and then save their car, so they don't need to, you know. And then here you could select the number of hours in the fee, and it'll calculate the fee, and then you press, it basically goes through. You can add your credit card and then pay, and then of course, yeah, you book it, and then here's so you can see that you paid for the spot. It will alert you 10 minutes before. And then here's the app. So these are all of the sensors. So this is all in real time. This is where all of the sensors are. And so it changes red to green as people pull out of these spots. So we basically included this in the app so users can plan their parking. They could see how many available spots they have. And then, yeah, here. So it's along the street.
Super cool. And so the app is not yet available to download, or it will be soon, Aretha?
It will be soon, yes, within next month. And here's the PNI sensor in ground. So that's the sensor we use. We place it underneath here. And so these, you can see it's placed under
so
all
cool.
of these spots.
That's awesome.
And then that's the, do you want, I can.
It's just so cool to see it just sort of lined up in a row there. I mean, I imagine,
yes.
I don't know if anybody from on the webinar here is in the Los Angeles area, but I imagine you'll come across one of these pretty soon. If you do, take a picture, send it along in Discord. We'd love to see it. This is so cool.
Okay.
Thank you.
Yeah, no promise. Yeah, and then here's the gateway again. It's installed in the traffic signals.
It's such a good gateway deployment location. I mean, people who are on this call who have deployed gateways are definitely jealous of where that's at. I am myself. It's a fantastic coverage location.
Awesome. And then that's it. So our closing thoughts, we will use Helium for our other IoT for utilities. We're planning to use it for utilities and the sewer, or and then also we're trying to, maybe combine some data and with machine learning and see if we can, create some useful insights. Our website is nobel-systems.com. And so also, Dan, do you have anything to say?
Well, I've actually got a couple
sorry.
questions that you might be good
Sorry.
for, Dan, if you've got a second.
Okay,
Yeah, sure.
Yeah, so thank you for that, Aretha. Fantastic presentation. Thank you, Tanmay, as well. So we're gonna keep this slide up for a few minutes if people want to take down some information. Also, it looks like Dan is active here in chat, so feel free to ping him there if you've got questions. So let's take a few questions here in the backlog, and I think Daniel will be good for a few of these. So where did that one go? Let's see. Oh, well, so might be for Dan, might be for Tanmay, might be for Aretha. So who owns the traffic lights? And who gave permission to put the gateways up on those traffic lights?
I would imagine that would be the city.
Yeah.
So, yeah, so they typically own the rights there, and then they can do the pole attachment. So,
right. Okay.
So it usually works.
Yeah, I mean that's city to city things tend to be different, right? When you go for that sort of thing. I remember in San Francisco, Helium was actually trying to get coverage deployed for a very, very old version of what is now the hotspot. And we, started with the town, and they kicked us over to PG&E, and it was a whole sort of morass. Certainly hard to navigate. Okay, what are some of the complications that are associated with the sensors that Nobel has dealt with so far? So maybe take that more generally. The sensors that you've sort of built, or the use cases around them, like what sort of complications have you seen generally?
Yeah, I'd have to throw that one back over to Tanmay. He's more familiar with the Huntington Park project.
I think there are a little bit complications that come up. Like sometimes the sensor is not calibrated as it is supposed to be, like as robust as it is supposed to be. So sometimes while doing a test, I mean, we were doing testing like last month, or maybe like last 3 weeks. It looks like we were getting some of the packets which were unrecognized than what it was there in the documentation. So we had to kind of go manually and calibrate those sensors, but that's kind of fine. It's part of the testing process. So those are only the challenges we face. That's all.
Interesting. That kind of answers the question here that, sorry if I'm saying your name wrong, Mihail Naka was asking, how do you do QA? How do you deal with incomplete or erratic data from sensors? Basically, part of your standard QA process, you're filtering out these issues and sort of improving as you go. So let's see, general question for you, Dan. So outside of sort of these, this sort of application here for parking lot sensing, like what else is Nobel sort of spending a lot of time on? Where are you seeing a lot of your IoT business growth coming from?
Yeah, so for utilities, they're looking for ways to kind of monitor and kind of manage a lot of their different assets. So there's a variety of different sensors that are available. We provide one for utilities to monitor pressure in a water system, but there's other sensors we talked about earlier, Mark, like air quality, temperature, rain. All these things have impacts to the city, to the business. So there's any variety of different sensors. We can connect those through the Helium network, and then we provide the visualization and access to the people at the city itself and to their customers. So Nobel is really good at connecting business to the customer directly, and that's the platform that really provides the value to the sensor network.
And so your end customer tends to be, in this case, it's a city. But it's a city, it's a utility, that sort of caliber of entity.
Correct, and it's a way to connect and share information with citizens or visitors, in this case to the city. With this application, we can provide dynamic pricing, parking availability during special events, and probably equally as important, showing reserve spots for special needs, locations, access to the hospital, to the grocery store, that sort of thing. So you can reserve these sites, spots ahead of time, and know where the closest available spot is during the special event. for an activity, if you're trying to go to a doctor's appointment or something like that, a lot of value to having this kind of information available.
Yeah, I mean, I'm ready to use it. I mean, I haven't really been driving too much outside the house, but I'm ready to use it. All right, so James B is asking, how do you keep people who want to cover up the sensor? I guess that might be, how do you keep people from covering up the sensor? I'm not entirely sure what the thinking is there. Maybe Tanmay can address that.
Well, I mean, I would say that, there's any number of different ways to kind of, try to circumvent the system. However, the system is going to be constantly monitored. If somebody's trying to cover the sensor, they obviously haven't paid for the spot. That's going to get flagged.
Right.
And, so all those alarms are going to go out, and then somebody's going to be able to monitor those in real time and then take action.
Interesting. Okay. So Gonzalo is asking, what happens if you park between the sensors? Is that possible? Can that be done?
Again, I think it's kind of the same question. Like if you're not properly parked, if you're paying for the spot and you're on a motorcycle and you don't make an attempt to cover the sensor, it's going to show up in the application that you're not properly parked. So I don't think that you'd be able to effectively pay for the spot, and therefore it's not a valid parking situation.
Right.
So,
okay.
So yeah. So a lot of those things, those are going to be alarmed, and you'll be able to see in the app, and then of course, somebody at the city will be able to tell that something's not right, and then action will be taken to correct that activity.
Got it. Huh, okay. All right. So let's take let's say 2 or 3 more, and then we'll call it. We're sort of running over time here. So Keith is asking, have parking revenues in Huntington Park gone up as a result? I mean, what's the city using for sort of success criteria for this deployment? Do you guys have any insight into that?
Go ahead. Go ahead, Dan.
No, I was going to say, parking enforcement, that's a big deal. People park longer in a 2-hour spot than they're supposed to. So being able to get that revenue, get the spot freed up, and then, not have to actively send somebody from parking enforcement to go out there and enforce, right? So, so there is that saving of resources by not having to have a person go out there and manually, take action. And then, be more efficient in processing your enforcement revenue and that sort of thing. So yes, there's definitely been a quick return on the investment there for Huntington Park.
That's super cool. Here's an interesting question. So how does one use a parking spot like this if they don't have a phone with an app on it that they can download and sort of pay through?
Yeah, I think we'll have signs on the light pole to, download the app to pay for it. So we can force the user to download. But there is a manual pay station, so that will work.
Right. That's good. So there's a question from Mark Beatty. Let's see. So John Fitzpatrick asking about batteries. So they last, I think Tanmay said 5 years is the target there.
Mm-hmm.
And then let's see the last question here. So any video monitors deployed in conjunction with this system? Do they have some video they're watching as well, or no?
No, I think just, or I'm not sure, Tanmay, do they have CCTV?
I'm not aware of that. Maybe it might be.
Yeah, I think in this application they don't, but that could also easily be incorporated if they have CCTV TV available throughout the city or in a parking garage. Then we can definitely take an input from that and have that kind of integrated into the system as well.
Cool. And then a good question to end on here from Richard Bryden. What's the communication from the pod to gateway? That's the Helium LoRaWAN. Yeah. All right. So we'll call it here. I think I got to all of them. If I didn't get to you, you can email me, mark@helium.com, or you can email anybody here on the screen. So with that, I'll just say thank you to Dan, to Aretha, and Tanmay. I guess, before I go, do you have any questions for me? I've sort of been monopolizing the conversation one way here. Anything on your mind about Helium? It's okay if you don't. No? Okay. All right, so that will leave it. But I'll just say thank you again to Aretha, Tanmay, and Dan, and to everybody who came and spent 45 minutes with us. This is, one of the coolest applications that we have on the network. It's got a lot of sensors. It's something that people can sort of appreciate and use, right? If you're in Los Angeles and hopefully other parts of the world or other countries soon, you can maybe use one of these sensors and use this application. Yeah, so thanks to the group. Thanks for people joining. And we'll catch you on the next uplink.
Awesome.
Great. Thank you.
Thank you.